Okay, y'all, let's get started. So I apologize for the big room. This is kind of one of those tweener classes where we couldn't find a 90 student room. We have about 85 students in here, and this room accommodates about 140, so seems a bit big, but we will make do. My name's Brad van der Zanden. For those of you who have not had me before, this is CS 465 and 565. This course is a course with a split personality. Half of it is databases and half of it is scripting languages. So the intent of the course is to introduce you to both of those topics. They're both important in the real world. They actually do interact in the real world as well, because one of the big uses for scripting languages is for website development, and one of the big things used by the back-end servers to tend to those websites are databases. So there will be a bit of continuity as we go from the database portion of the course to the scripting language course, although I must admit it probably, for the most part, will feel like two different courses. Nonetheless, it's worked well in the past. I'm sure it will work well this time, too. Before I go any further, this is an important website that you should copy down somehow, because it is the main website for this course. It's where you will find just about all of the course information. And you'll notice that it says CS 465. It's the same site for the graduate course. So one site for both classes. And I'll assume that you have it down. So this course has some objectives, both for the database side and for the scripting language side. Each part of the course will be roughly 7 weeks. We actually work with 14-week semesters, roughly speaking. So we split it almost exactly in half, with 7 weeks with databases and 7 weeks with scripting languages. So on the database side, first of all, we want to tell you what is a database, and I'm going to abbreviate it as DB. We want to familiarize you with how to use a DB. And for this class, we will be using a public domain database called MySQL. It's a public domain equivalent to SQL, which is probably the most widely used type of relational database on the market today. And we'll talk about what relational databases are in a bit. We're going to talk about the theory behind a particular type of database called the relational database. It's the type of database that we will be concerned with in this course. It's also the reason that CS 311 is a prerequisite for this course, because you kind of need to have had CS 311 in order to understand the theory behind relational databases. Then we talk about the design of databases, both at the data level and at the physical level. So there is, we'll call it the logical design of DBs, so how you put one together, how you structure the data, so how to structure data. And then we talk about the physical design, which is how you store it, using actual data structures like extendable hashing or B-trees, which haven't had this far, but we will get to them. So physical organization. On the file system. So that's the first 7 weeks of the course. Basically, how do we store a large amount of pretty structured data? And then the various mechanisms we have for manipulating it, for modifying it, for designing it, and for efficiently accessing it. The second part of the course, we talk about scripting languages. And many of you have already had an introduction to them in CS365 because I covered them for the first time in 365 last semester. But if you haven't, and I'm going to allow for that possibility, we're going to start by talking about what they are and how they differ from traditional compiled languages. Then we'll go into 3 specific ones, which are Perl, PHP, and JavaScript. So each of them we'll spend about 2 weeks on. You won't become an expert in any of them, but you'll get a good feel for their basics. We go into Perl because it's widely used, not just by computer scientists, but by other disciplines as well, especially the sciences. And it's good for data extraction and report generation. It's also used by a lot of system administrators, but we're really not going to get into that part of the Perl. We may talk about it briefly, but we're going to be more concerned with its data extraction, report generation capabilities. And then PHP and JavaScript are, in some sense, twinned. They are web-based languages. PHP is typically used for server-side scripting. It's the most widely used language for server-side scripting. And JavaScript is the most widely used for client-side scripting. So you're going to be getting kind of a basic introduction to how websites are organized. We're not going to really talk a great deal about website design. I will spend maybe one lecture talking about some of the do's and don'ts, but we're more concerned with the implementation of websites and how that gets done via PHP and JavaScript. So that's going to take us then through to the end of the semester. And as I said, the objectives with Perl, PHP, and JavaScript is to give you a basic knowledge of their core design ideas, but we won't have time to turn you into an expert on any of them. Before we go further, I'd actually like to introduce the 2 TAs for the course and let them actually take off. So actually, Charles, I'm going to have you come down here. I know you don't like to probably, but and is Muhammad here or not? Yep, there's Muhammad. So both of you come on up. It's easier just to let everyone get a good look at y'all. So Muhammad, Risa, or I'm not sure.
Oh, yeah, just Muhammad. Yeah.
Muhammad Risa, Charles Phillips. So Muhammad both of them will be grading homeworks for the course. Muhammad will also be holding some office hours. Charles, not so much. If you have a question about your grade on a homework assignment, you can make an appointment to see him. But Charles has other duties as well. How many of you are taking 580? No one. Okay. Well.
Actually, Monday's 2 to 4.
Okay. Well.
I'm there, so.
So if you have a need to see Charles, you can see him Monday 2 to 4, and we'll post that. We'll get some office hours from Muhammad too. So take a good look at them. They're the bad guys. I'm the good guy. No. So at any rate, and you all are free to go. So thanks so much. See you both tomorrow. Okay. So let's, before we go into anything else, we'll go over some of the course details, some of the logistics. So my office is MinCal 312, and you can see my office hours there are Tuesday and Thursdays. We occasionally have faculty meetings on Thursdays from 3:30 to 4:30, like today. So in fact, I won't be there today. But my reason for putting it on Thursday from 3:30 to 4:30 is almost none of you can complain about the fact that you have a class at that time, because the CS department or the EECS department does not schedule any classes in the 3:30 to 5 o'clock time slot, specifically so that faculty are free from meetings and the like. So I knew that Tuesday 2:15 to 3:13, not everyone will be able to see me, but I do know on Thursdays from 3:30 to 4:30, you can. Okay, and I have a TA meeting on Tuesdays in that 3:30 time slot, or else I would have put my other office hour there. Email bvz@eecs.utk.edu. Please, only personal things like needing to miss an exam, because we're going to use Piazza for this course. Most of you should have used Piazza in the past, and that's where I want you to typically post your questions, commentary, and the like, because that way everyone can see the questions. We're all on the same page. The TAs are on the same page. They're not giving you one answer to a question with me giving you another answer. So I try to use Piazza for all administrative stuff, except, as I say, personal things like needing to miss an exam or having a medical emergency. I don't need to know if you're going to miss a class, okay? Unless you're missing a midterm. I tape all my lectures and upload them usually within a day of class. So if you miss the class, simply go to the website and view the video. Okay. We just saw who the TAs for the class are, and their contact info will be posted on the website. We've also already gone through the material that we're going to be presenting with both databases and with scripting languages. There are 3 places to find things for this course, the most important being the website I already gave you. It's got the general course information, the homework assignments, the video lectures, the assigned readings, lecture slides. So all lecture slides are up there. We use Piazza for course announcements, discussions. If that's for no other reason, then that's where I make my course announcements. I don't make course announcements through Blackboard. I make them on Piazza, so make sure you enroll. And then the homework and project submissions are done via Blackboard. That's the only use that we have for Blackboard in this course, other than for Grade Center. Your grades are kept there. I'm wrong. We're also going to have quizzes, Blackboard quizzes, so that will be a second use for Blackboard in this class. The book is a tome by Connolly and Begg. They are Irish. I like their writing style a great deal, which is why I use it as opposed to, say, authors that are American. You'll have to get used to the fact that they like to use pounds rather than US dollars. But hey, money is money. You'll find that a lot of uses for databases are in the business realm. So a lot of our examples actually are drawn from the business side of things. At any rate, I often get the question, do I need the latest edition? The answer is no. You can get an earlier edition. The only thing is that the questions are sometimes assigned from the textbook, and if they may not exactly match up from an earlier edition. So if I assign question 3 from chapter 6, it might not be question 3 in an earlier edition. Often a Good Samaritan, which is not me, but a Good Samaritan for the class, will volunteer to scan the appropriate exercise pages from the textbook and upload it to Piazza so that anyone who doesn't have the 6th edition at least has access to the appropriate questions. So that's something that if you don't have the 6th edition, you have an earlier edition, you can make a plea early on Piazza and ask for someone to scan that and upload it. Grading scale for the class is similar to what it is most of the time at UT. I'll give pluses for good composite scores near the top of the range, minuses for stuff near the bottom. I don't give A minuses in this course. I do in 102, but I don't. So if you get a 90, you will get an A. Conversely, because of that, don't expect mercy when you get an 89.85 and you ask me to bump you up to an A. You won't get it because that's a pretty broad range for an A. So there's several elements to your grade. It's a little bit different depending on whether you're an undergraduate or graduate student. You can see the percentages there. You can see if you're a graduate student, you're doing a project. The project is released usually sometime in October. It's a database, basically design of a pretty simple database, and it's due November 12th, and you demo it up until November 19th. I intentionally put it before the last week of the semester because that way you cannot complain to me about the fact that you have 1,001 things due the last week of the semester. It's also actually a very good way of spreading out your workload. So that's not up yet, but I typically don't assign the project until I'm pretty much done with the database segment of the course. As I say, the project usually takes a couple days to do. It's not going to be a huge drain on your time. There's a new element this semester, which are quizzes. I'm going to have Blackboard quizzes that I will release right after class. They'll be due 48 hours later. This is the only class that will not have a Blackboard quiz. So there'll be no Blackboard quiz today, but starting Tuesday, there will be. And they're going to constitute a small part of your grade. I dropped the 3 lowest ones because I understand you may forget. You may have some kind of extenuating circumstances. So please don't ask me to make up a quiz. The answer is no. I just can't manage with this many students to have make-up quizzes, extensions, etc. I just handle it by dropping your 3 lowest quizzes. If you think about it, there's about 20 to 25 quizzes, so I'm dumping about 15% of them. So it's not, I don't think it's too hard. One thing is that, unfortunately, if you miss a quiz, you can't see the questions. I wish Blackboard had a way of making those questions available to you, but it doesn't. In that case, you're just going to have to ask another student to provide you with the questions and the answers. And I strongly encourage you to do it because I sometimes pull test questions from the quizzes. So one thing that is perhaps going to be a little different is the midterm and final will have a substantial component of multiple choice and multiple answer simply because of the size of this class. We have about 85 students. We actually do not have very much TA support for it. And if you do the math, it can take a good test that had problem solving and a lot of working out of things could easily take about half an hour to grade per student. It's 85 students, half an hour each. It's 42 hours. Sorry, I don't have that much time. I have a lot of other responsibilities. So unfortunately, the only fallback I have is to multiple choice and multiple answer with maybe one or two problems to work out. The same thing is going to be true for the homework assignments. We're probably only going to be able to grade about 2 problems per homework assignment. And the way, and again, it's just because we have about 20 hours of TA support, we have 85 students. That means that the TAs have no more than about 15 minutes per assignment. Okay, so it's not a lot of time to grade. And so there's only really time to grade about 2 problems per homework assignment. So I'll tell you in advance, you know, these are the 2 that are going to be graded. What I hope to do is some of the other ones, have you do them as in-class exercises. And we can, you'll be in class, you'll be able to work on those with someone else and just, we can then go over the solution. So that's my solution to this kind of issue that we don't have a lot of manpower for the course. And that's also kind of, for those of you who took 365 with me, you know that I favor something called a flipped classroom, where you typically come to class having already viewed a lecture or having read the material, and then I do hands-on exercises in class. This class, I'm not going to run that way, but it's going to have an element of that where I may well give relatively short lectures on some days. Some days, like when I get into the theory, I'm going to have to pretty much lecture the entire class. But there's other days where, quite frankly, the material is not particularly taxing. You should be able to read my notes, which, you know, I'm biased, obviously. I think they're quite good. And you can read my notes before coming to class. I can give a short lecture over them, and then we can do some hands-on exercises. For those of you who haven't had me or haven't dealt with a flipped classroom before, there's a good reason for doing it. The average adult attention span is no more than 20 minutes. With the advent of mobile devices, it's probably less than 10. And, you know, I'm not as good as Dr. Plank at lecturing, but I'm not bad. You're still not, most of you are not going to be able to hang in there for 75 minutes. Okay? It's priceless for me to look out after about 40 minutes when I'm just nailing a lecture and I'm thinking, I am in a groove today, and seeing half of you on your surfing your mobile devices. So, you know, it's just the way of the world these days. And therefore, it really helps to break things up by having hands-on exercises. And that's what I will try to do for a lot of the classes. Okay? And the reason for the Blackboard quizzes is that my experience is that if you're forced to review the material within 48 hours, that's very good. So the Blackboard quizzes are just there to force, they're about 20 minutes. They'll have a few multiple choice or multiple answer, fill in the blank. They're there just to force you to review the material. Look, I know many of you are not going to find it in your time schedules to be able to read the lecture notes before you come to class, but guess what? When you're doing those quizzes, that will probably be a time when you do go through the notes. So it's also a way to make sure that you go through the material shortly after we've gone through it in class. Okay, key dates. Dates where you really need to be here or some other reason. Midterm, right before fall break. Yeah, I know, everyone else does it, sorry, but that's when we're done with databases, and it's a good time to have you take the test, and then after fall break, we do scripting languages. It's just a good break point. The projects for the graduate students are due November 12th. By the way, if you want to do, if you're an undergraduate wanting to do contract by honors, I don't think that's so much done these days because we actually have explicitly designated honors courses in the CS curriculum, but should you decide that you want to do this course, contract by honors, that will be what you do. You will also do that project. Then the final is in here December 4th from 12:30 to 2:30. So that's a quick rundown of the logistics. Are there any questions? Yes?
Is the final cumulative?
No, it's on scripting languages. And normally what happens, actually I'll take that back. Normally what happens is that you have not had enough time to deal with physical design of databases with extendable hashing and B trees. And so what usually happens is there's one question about extendable hashing and B trees on the final. So there's one database question on the final, and the rest of it's scripting languages. That's how that usually goes. Okay, other questions? Yes, Brian.
Has anything for this course been affected by the lap switch, the hydro lap switch?
Should not. Okay. It should, in fact, the fact that basically all our machines are now Linux is pretty good. So I don't see an issue. That said, no, we've always used Hydra as, that said, I guess we haven't fully tested everything, but I don't think the change of Linux system should be a big deal. For those of you who don't know, we've switched to Red Hat Linux from some other Linux, so hopefully there won't be any big deal. Other questions? Okay. For those of you thinking, Piazza, he said we better enroll in it. How do I do that? There it is, the sign-up link for the course, right there. And the link for discussions right there as well. So please, at some point soon, do sign up for that. You'll see that under general information, office hours, required textbook. The required textbooks for scripting languages, there are none. Basically, my notes plus there's a great site, w3schools.com, that pretty much covers it. I really do not recommend that you buy a book for the scripting language part of the course, but for those of you who must have a reference, I've listed a few possibilities there. We've covered everything else. And then lecture notes, as you see, every day we have some topic, assigned reading, slides, if I have them, so not all days have slides, and then homework when it's assigned. So for example, your first homework assignment will be assigned on September 1st and will be due on September 10th. Homework assignments are due at 5 p.m. 5 p.m., remember that, not midnight. And to encourage you to hand them in early, if you get them in 24 hours in advance, you get 5% extra. If you're inside the 24-hour window, you don't get extra credit, but you're not docked. You are allowed to submit homework late, but should you do so, there is a 10% late penalty, and you can submit it up to a maximum of 3 days late. So if you're 3 hours late, it's a 10% deduction. If you are 27 hours late, it's a 20% deduction, and so on. There's a couple homework assignments where I need to be able to put the solutions up immediately because of exams, and those you will not be allowed to submit late, but they're clearly identified on the syllabus. Okay. Also on the homework assignments, it's fine to talk with your friends about your general strategy for solving the problem, but it's not okay to copy their solution. So please, when it comes time to actually write your answer to the homework assignment, do that by yourself without a friend being there. One good technique that I've heard works well to avoid copying is if you are working with a friend, you work here, your friend has their computer there, you can't see each other's screens, and while you can talk about what your problems are, you don't end up copying each other's work. Okay? Dr. Planck says it much more eloquently than I do about what he thinks about cheating and plagiarism, but I do not like it either. And at best, you will come off with a 0 for that assignment, and at worst, I'll get really miffed and refer you to academic misconduct. So please do stuff on your own, especially because we're not talking about onerous homework assignments this semester. 2 problems, it's not, going to kill you. Okay. As I said, submissions will be on Blackboard. They will be due at 5 p.m. One thing that I learned my lesson on now is that when you write your SQL queries, make sure they work. The TAs will be testing them using automatic scripts most likely. So having queries or programs that almost work isn't going to cut it. You need to have stuff that actually works. In the past, what has happened is students have said, well, they just wrote out the query. I thought it worked. I never actually tested it. Why didn't I get credit for it? Well, it's because it's like a program. It works or it doesn't. So please make sure that you have tested and run your queries before you submit them. Okay. Anything else there? So homework, any supplementary files, and as I post video lectures, they show up here too. So even today, I'm taping this one, and it will show up later today or early tomorrow under the lecture slides. Okay? Good to go? Okay. So the rest of today, I just want to basically give you an introduction to what is a database and why we use them. Okay, why we use them in preference to something else like just regular ASCII text files, for example. So the first thing is, whether you realize it or not, databases are ubiquitous. So they are the back-end engine for a lot of websites. They're the bread and butter for anyone involved in e-commerce like eBay or Amazon is going to have a pretty extensive database backing their website. Okay, keeping track of inventory, keeping track of credit card numbers, keeping track of invoices, keeping track of when stuff is paid. Here at the university, databases are used to keep track of your grades, your personal information, your financial information. For me, it's used to keep track of my personnel records. So databases, widely used. We have a very basic definition for them. It's a structured collection of related data and its description. You might think, and its description. There's a couple key words there. First of all, structured. So databases do have one important drawback. They don't work well with unstructured data. And there's been a lot of research into other ways of organizing data when it's not structured. For example, there's object-oriented databases. Unfortunately, we will not get to them simply because we do not have time. I only have time to go over the most common and widely used type of database, which is a relational database, and it requires that the data be pretty structured. Okay, XML, we will briefly talk about it when we get to scripting languages. XML is a markup language that's also used to handle what we call semi-structured data, data that has a fair amount of variation, but the variation is relatively constrained. Okay, databases aren't like that, or the kind we're going to be considering. The data is very well structured. It doesn't have very much variation. For example, with a credit card, everyone's credit card pretty much has the same information, whether it's American Express or Visa or MasterCard or Discover. There's a name, there's an identification number, there's perhaps a PIN on it, there's a balance, there's a set of transactions against it, a very well-defined set of fields that you can store. So structured is important. Second thing is you're thinking description. That sounds kind of vague. Description means basically the fields and their types. So with the credit cards, you have a name field. Its type is a string. You have a account number field. Its type is an integer. That's what's meant by description. So you can actually think of it as basically the fields and their types. Their types. And which fields are clustered together into something we call relations, which we will get to. So you needn't worry just yet about what that is. Other than that, it's kind of like, think of it as a file. Which fields get clustered together in a file? You can think of a relation as a file right now. Okay, so you have this database. It's a structured collection of information. And then you typically have two languages associated with it. One is a data definition language, which I will typically abbreviate as DDL, and one is a data manipulation language, which I and the rest of the community typically abbreviate as DML. So the data definition language defines the structure of the database. Think of it as the variable declaration section of a program. So it's the one that's declaring the fields, declaring their types. It is saying which fields are clustered together into files. As I say, a good way to think of a data definition language is as the variable declaration part of your program. The data manipulation language is the one that allows users to insert, delete, retrieve, and update information in the database. So the data manipulation language is a query language that allows users to insert, delete, update, and retrieve information. So the data definition language typically is used by a DB designer. Remember, we said we'd talk about database design in this class. And the data manipulation language is typically the database user. Remember, we said we'd tell you how to use a database. So when we talk about how to use a database, we're talking about the data manipulation language. When we talk about how to design a database, we're talking about the data definition language. So these are the two principal elements of what we call a database management system, so DBMS. So a database is part of a database management system. Okay, so you can think of a database management system as having a data definition language, a data manipulation language. So the data definition language essentially defines the database. And then the third big part of a database management system, so I'm going to put 3 here, this is still part of a database management system, is access control. So I'm sure you all feel really good when, has anyone ever been notified that their credit card number has been pilfered? So, a couple of you. Fortunately, not as many as I might have thought. So, anyone who has had their credit card pilfered or, worries about it when you hear about these breaches knows that security is a huge issue in databases, and that is a constant game of, in effect, spy versus spy, with hackers trying to break into databases and the white hats trying to keep them out. So there's a number of things that comprise access control. Security is clearly one. So you're wanting to prevent unauthorized users from accessing the database. Okay, but there's more to it than just that. So security, you're preventing unauthorized access. There's also the issue of data integrity. Okay, and that means that the data is consistent. For example, you try, if at all possible in a database, we try not to store the same piece of information twice. We can't get away, we can't always do that. For example, there are keys like personnel numbers that have to be stored in multiple places in the database. But whenever you store a piece of information multiple times, you run into the possibility that when you update it, you don't update all copies of it, and then the data becomes inconsistent. So that's what we mean by data integrity. We need to ensure that when data is updated, if there's multiple copies of it, that all copies get updated. How many of you have heard of NoSQL? Most of you. Okay. Very trendy. One thing that NoSQL does is it relaxes the restriction on data integrity. It's willing to tolerate temporary inconsistency in the database as long as it converges to consistency within some period of time. So NoSQL relaxes what's called transaction control. It allows multiple users to simultaneously update things, and there may be conflicting updates, and NoSQL is fine with that as long as eventually the updates converge to one user's update. Now, that doesn't always work well. If you're Amazon and you have one book left and 2 different people get to grab the book, that's bad, and therefore I doubt that Amazon uses NoSQL in order to deal with its databases. On the other hand, I've heard that NoSQL is rather popular in the social media community. My research area is not databases, so I can't really get into a discussion with you on NoSQL. I just know that within the social media community, it's not so important if the data, when it converges to consistency, doesn't necessarily, the data is more fluid. There's no one, quote, correct state. And so as long as it converges to a consistent state, we're good. Whereas with Amazon, it's really bad if two people get the last book. You can't really split it like Solomon did. Okay, yes?
So yeah, I've done a lot of work with NoSQL, and so Google search engine big table is what runs behind it. It uses NoSQL, and I think the reason social media uses it a lot because it's really good for unstructured data and doing like machine learning stuff.
Mm-hmm.
And it's naturally not ordered and consistent. So I've seen it used a lot of stuff like that.
Okay, so it's another thing. This is something that I've sometimes talked to friends in the community, and sometimes they seem to say it's good for unstructured data, and some other times I get shaking the head and sighs and the like. So, so it does, I guess, get used somewhat for unstructured data. Okay, so when you hear NoSQL, this is the big thing that it is relaxing. We will not be relaxing that in this class. We will be concerned with data integrity. Concurrency. So we really, like Amazon isn't very interested in having only one user at a time able to access their website. Amazon would not have grown into $1 billion firm if only one person at a time were allowed to access their database. So it's really important to allow multiple users to access the database simultaneously while ensuring data integrity. And that's typically done through something called transaction control, which we are not going to talk about in this course because it's an advanced topic, but you basically may be able to lock certain portions of the database and have the user batch a certain set of user updates and then make sure that all such updates get committed before the transaction is considered completed. If you can't finish all of the transactions or all of the updates, for example, because the user gets disconnected in the middle of their credit card entry, then the entire transaction is canceled and the data is rolled back to a previous state. Again, fairly complicated. We won't get into it, but transactions are what are used to deal with concurrency. Okay, recovery control. Okay, so restoring the database to a consistent state after a software or hardware failure. Again, an advanced topic, we will not discuss it in this course. For those of you who've taken courses from Dr. Plank, you know that until recently his research area was error correcting codes. And error correcting codes are an integral part of recovery control, adding additional bits of information to your data so that you can check and make sure that the data hasn't been corrupted in some way. And if it has been corrupted, then being able to recover that data. Okay. Last thing is views, what I'm going to talk about. And that means giving each user an individualized view of the database. Each user gets an individualized view. Okay, so a manager and a employee should have different views. Same thing in Blackboard. I get to see all of your grades. You only get to see your particular grade. So we're actually seeing, each of us is getting a customized view of the Blackboard database. Okay, so that's a big part of access control, is that you want to display different information to different users. Obviously, there's some information that some users should not have access to. Views provide a way of giving users the appropriate information. Views are something that we will consider in this course. It is something that the data definition language is able to declare. Was there a question or not? Just trying to stretch out the arms. Okay. So those are the basic features of a database management system. And there's competitors that are out there. The biggest competitor before they were really formalized was simply, for lack of a better word, just say structured, so let me say the competition. Okay, so the big one was something called file-based systems. This is what databases essentially replace. These days you also have things like XML, is the other big alternative. Then you have things like obviously object-based languages or NoSQL, where you're trying to get something that will handle unstructured data. So I'm talking about more the competition for structured data. And the big competition really would be what existed in the 60s and 70s, which were file-based systems, and then XML, which is a more recent addition. It's a markup language. Language for data, where you use tags to identify data. And we'll talk about this later in the course. So the system that kind of reigned in the 60s and 70s was that every department in a company kept its own set of records. So let's say that you had a property management company. And the reason I say property management is you'll see that the Connolly Bake textbook uses a property management company called Dream Homes. It's a great name for a company. I can't believe someone hadn't already snapped that one up. But at any rate, their running case study throughout the book is the Dream Home real estate or property management company. And back in the 60s and 70s, each of its departments would have had its own set of files. So the leasing department would have kept a set of records about leases. The owner's department or the sales department would keep track of its contacts with customers. The, realtors would have a separate set of records for the owner. So you might have a department that dealt with owners, a department that dealt with clients that are leasing the properties, and then another department that dealt with leases. And each of them might have their own set of files. And maybe the leases department used COBOL for its file management, and another one used, say, that time C didn't exist, so we'll say Fortran, and another one used PL1. But the idea is that there wasn't always a lot of cooperation between the different departments. Each department might have its own set of data processing personnel. So you might have the lease department, you might have, we'll call it rentals, and we'll call, that's for getting clients and showing them properties, and we might have, say, owners. So we might have three departments, each with its own set of files, each with its own set of programmers that sit there. Whenever a manager needs a query, then the manager asks the programmer to create a custom query, the manager can't do it him or herself. So we basically are looking at a situation where there's walls between the data. And this led to a lot of problems. Okay, so we have file-based systems. And they are a collection of unrelated, for some reason, I'm not getting, well, my ink is not working particularly well, so I'm going to have to take 1 second here. And actually, I don't like to do this, but I don't really have much other choice. I'm going to actually go to my notes. I much prefer writing it out. The reason is, just as a pedagogical thing, this kind of stuff can put you to sleep fast. It's much better if I write it out and you're forced to follow along. This way you can just sit there and it's easy for you to space out. But unfortunately, I can't write up here because you're not going to be able to see it easily at the back of the class. And whoops, there we go. Okay, so, whoops, whoa, there we go. So a collection of unrelated files and a collection of application programs that perform services for the end user, such as production of reports. Okay, so there's a whole bunch of issues with this. First is the fact that the data is separated and isolated, and you can't cross-reference the information from different files. So for example, if I want to produce a list of all properties owned by, say, Joe Keogh, and let's say that we want to know which of his properties are leased, then we really need to cross-reference information between the lease department and the owner department. And if those two departments are separate, it may not be easy to cross-reference them. One may be stored in COBOL format, one is stored in Fortran format. We can't easily make them talk to each other, so that was an issue. Duplication of data was an issue. Remember we talked about data integrity and consistency. Well, leases might keep a bunch of information about Joe Keogh, such as his name, his street address, but so does the owner's department. And Joe calls up his realtor and says, hey, I just moved to Knoxville, here's my new address. Person in the realtor's office forgets to tell the leasing office that Joe's address changed. Now you have inconsistent data and it's no good. So duplication of data was a problem. I just told you incompatible file formats. Fortran and COBOL have different file formats, so it's not easy to make to share data. Data dependence meant that the structure of the files was hard-coded in an application. You would have your variable declaration section that laid out the record and said, okay, the last name is 20 characters and the address is 30 characters and the ID number is 10 integers, and it was hard-coded in the programs. And if someone needed to change that, then they had to ask a programmer to go in, find all the places where we had declared the name to be 20 characters and change it to be, say, 30 characters. Okay, this was, by the way, great for job security for programmers. Okay, all this stuff. It's like, oh, you need to be able to tell me which properties are leased for each owner. Guess you can't do that. That would be moi. Okay, that would be about 2 weeks, by the way, but don't worry, I'll have it to you in 2 weeks. Yeah, there's some issues. I mean, Yeah, they're in different formats, but don't worry, I'm the pro, I'm the expert, I'll make it happen. Okay, so very good for job security, but very expensive for the companies. Okay, there you go, fixed queries, proliferation of application programs, because every time you want a new query, the poor manager has to ask someone to generate the report from them. Yeah, my inbox is backed up. Might be a month. I'll get to it. Or you could hire my brother. He's looking. I mean, he got fired from his last job. I won't mention that. But you get the point that every time you need another report, you have to ask for it. It may take some time. Of course, you have to manage all the other programs that have already been there, so you get this proliferation of application programs. You have to hire more people, or you can't generate timely reports. So there was this big problem. Researchers spent a lot of time in the 60s and 70s looking for answers. There were some database systems. You may hear sometimes of hierarchical databases and network databases. They did not solve all the problems. And then in the mid-70s, a person by the name of Codd, I think it's E.F. Codd at IBM, T.J. Watson, came up with this idea for a relational database based on the theory of relations. And it was very elegant. He eventually got an ACM Turing Award for it. But the problem was, at the time, computers were not nearly as powerful as they are today. And it took about 10 years before they were able to actually make the algorithms efficient enough in order for the relational database to work. So it's not until the mid-80s that relational databases start to really make it into mainstream commerce. And of course, now they're quite dominant. So they have a fair amount of advantages. The big one is flexibility for the end user. Okay, and the operative word here is they provide a declarative way to specify queries. So instead of having to write a big detailed program to generate a report, all a user has to do is provide a description of the information that they want. Now, you may not think that this particular query looks particularly easy, and I won't claim that it is, but it's it very succinctly expresses a report that could take a lot of time to generate. So in fact, what we are doing here is getting the names of clients that live in Joe Keel's properties. So we're saying what we want is the client's first name and last name. Okay, those are the columns for our report. Okay, then there's several files that contain this information. The client file, the private owner, the property for rent, and the lease files contain the information we need. And then we have to specify our conditions. So we're interested in the owner whose last name is Keo and whose first name is Joe, because we want to know which clients live in his properties. Then we need to match up Joe's owner number with the owner numbers in the property for rent. So basically, Joe has several properties for rent, which are in the property for rent file. Now, not all of those properties are leased out. Regrettably, Joe has some dumps, and we haven't been able to lease out Joe's, restoration projects yet to the right customer. So not all of them are rented out, but they're there in the property for rent database. And therefore, we have to cross-reference the property for rent with the lease database to find, well, which of Joe's properties are currently under lease. And finally, from the leases on Joe's properties, we're able to obtain the appropriate clients. Okay, and using the client number, we cross-reference into the client file to obtain the client's first name and last name. So yeah, this is going to take some getting used to. I don't claim this is super easy. This is, however, a lot easier to specify than a big program that, think of the C program required to do this. You open some files, you need to start reading data into some structs or into some classes. You need to start setting up the formatting for it. There's a lot of stuff you have to do. Here we do it all in 6 lines, and the database is going to do the rest for us. You can teach a lot of users this language. Okay, so a lot of stuff is hidden here. Now, this is why it took 10 years in order to make commercial databases feasible. Because you have to write algorithms called query optimization algorithms that are going to figure out the best way to go out to these files and search them to find the information. Because Joe only has a few properties, and there's only a few in the lease file, so you need to find the most efficient way to obtain that information. So there's a lot going on under the covers, which we'll get to when we talk about the physical design of databases, but we won't even get into query optimization because it's a graduate level course. Okay? So databases control data redundancy, and the ways they do that is they decompose files. So when we get into database design, we're going to look at what are called decomposition techniques that basically split the data into separate files so that we place similar information in one file, but we don't duplicate it in multiple files. So for example, instead of the leasing office keeping track of Joe's address and the real estate office keeping track of Joe's address, there's one file that contains information about Joe. His address, his zip code, his particulars, they're all in that one file. Okay? And that way, we only keep his address in one place. Now, as I said, there is some redundant information that must be kept in multiple files. So Joe's owner number, it will appear in multiple files. No way around that. But we try to control and reduce data redundancy as much as possible. By reducing data redundancy, we ensure data integrity. Okay? Databases centralize the information. Instead of the information being spread all over the country or all over the office, it's in one centralized repository. File formats are consistent. It facilitates sharing of data. Okay? We have decreased maintenance costs. Euphemism for we laid off a lot of programmers. But no worries, because actually this was pretty dreary programming anyhow. And it wasn't exactly exciting. And I know because my first job kind of involved this kind of activity. It was in COBOL for a utility company in Dayton, Ohio. And we were essentially dealing with generating reports for the company. It was pretty mind-numbing. So not clear that you really wanted that kind of work. At any rate, since the physical structure is not hardwired in the application programs, like you don't have each program saying the size of the name field is 20 characters, it's a lot easier to change the size of a field. You typically keep that information in just one place. Backups are easier because the data is centralized. Security is easier to enforce because file access goes through one central location. Anyone know the flip side of that? what's the flip side of that advantage?
File access only goes through one central location.
Right. Makes it easier for the hackers too. Okay? That's one central location for them to get at your credit card information and your any other interesting goodies that they want to get their hands on. The other thing is if it goes down at that one access point, everything's down. Whereas if it was spread around, you'd only have one thing that was down. So it's the so-called dialectic, the strength is its weakness. Then concurrency is easier to control because all file accesses go through one central location. So it's a lot easier to handle. Okay, before you might have something happening in the leasing office and something happening in the real estate office, and they might be going on concurrently. So we're changing one of Joe's leases while Joe updates his information at the real estate office, and now because they're being done in two separate places, maybe some data gets out of sync. Okay, so disadvantages of databases, their complexity and their cost. You don't hand roll these puppies. You normally go over Oracle, sends you a pretty big bill, so they're expensive. Microsoft has obviously cheaper ones, but they're not as full-featured. You can get free public source ones like MySQL because, let's face it, academic departments aren't rich. That's why you don't get to use SQL. We cannot afford to pony up for an SQL license. So we use MySQL, which is actually quite good. Hardware, because they're so big and complicated, requires more hardware to run them. If you write a custom application, it would require less hardware. Performance, okay? If I write something in machine language or assembly language, I'll probably write something that runs faster than if you write it in a high-level language like C++. But who writes in assembly language or machine language anymore? Hardly anyone, because you don't get any, it takes too long. So it's the same thing here. Yeah, if you hand-tuned it, you'd get better performance, but it's just not worth it because it's the loss of performance is not significant, especially because Moore's Law has been rolled back a little bit, but not a whole lot, with processing power still doubling maybe every 2.5 years. It's just not worth trying to hand-tune things. Greater impact of a failure. This is, I think, one of the primary problems. Hackers, central location for a break-in. If Amazon's database goes down, well, tough luck for a couple hours, no business, and you lose millions of dollars. There is a fifth disadvantage that I don't have here. It's a big disadvantage these days. You have to have structured data. It doesn't work very well with unstructured data. So I am going to add that as number 5, which is you have to have structured data. Okay, so that takes care of it for today. Hopefully you have at least some appreciation for why we want to use databases. I know I didn't talk about why we use them in preference to XML, but I'll do that later in the semester. On Tuesday, we're going to dive into Chapter 2, where we talk a little bit about design, and then we back off of design and start into the relational database model, which we may or may not get to on Tuesday as well.